In this video, we're going to be looking at finding the inverse of a quadratic function with a domain restriction in standard form. So notice right here is our quadratic. F of x is equal to negative x squared plus 2, and x is greater than or equal to 0 is our domain restriction. So the first thing that we want to do is we want to go ahead and get prepared to do step 1, which is we're going to switch our x value and our y value to get the inverse. Now what I like to do is I'm going to go ahead and change f of x to a y, because that's going to be my y variable. So now that I have y, I'm going to put equals negative x squared plus 2. Now at this point we're ready to go ahead and switch the x and y. My x is going to move over to where the y is, and the y value is going to move over to where the x is. So when I rewrite this, it's actually going to become x is equal to negative y squared plus 2. So we've completed step 1. Now notice step 2 says use inverse operations to move the constant. So I'm going to move this constant value of positive 2 away from the y, because our goal is to isolate this y and get it all by itself. So it's a positive 2, so to move it, use inverse operations. I'm going to subtract 2. That cancels the 2's out, but I also have to remember to subtract 2 on the left side of the equation to keep it balanced. Now we're going to go ahead and rewrite it. So this now is going to be x minus 2 is equal to negative y squared. Now we do have our next step, which says divide out the coefficient of y. So we can't have a negative y, so we do need to divide out this coefficient of negative 1. So therefore I'm going to use inverse operations and divide the y by negative 1 to get rid of the negative sign. But I'm also going to divide the other two terms on the left side of the equation so that we keep it balanced. In other words, everything has to be divided by negative 1. And we know a negative divided by a negative becomes a positive. So all I'm left with now is simply y squared on the right side of the equation, and it's positive instead of negative now, and negative 2 divided by negative 1 gives me positive 2, and x divided by negative 1 gives me a negative x. So now that we completed step 3, we're going to go ahead and we're going to complete step 4. So notice step 4 says take the square root of both sides, and that's because we need to get rid of this square right here. We don't want y squared, we want y equals. And to get rid of a square, something that's being squared, we have to do the inverse operation, which is to take the square root of it. That basically unsquares it. So I'm going to go ahead and write a square root symbol over it. I'm also going to do it to the left side, because whatever we do to the right, we have to do to the left as well. And notice that cancels out the 2. So my radical cancels and my 2 cancels, and I'm simply left with y all by itself. Now over here on the right, I have the square root of negative x plus 2. So I'm just going to rewrite it. Now I have isolated the y. I have y all by itself with a coefficient of positive 1. So at this point we're nearly done, but what we want to do now is we want to go ahead and complete step 5. Another thing that we must remember is when we take the square root of something, right, it leaves us a positive and a negative value. So this radical, we have a positive 1 and a negative 1. So as we rewrite the equation with y on the left hand side, only using a positive square root, the reason I mention this positive square root only is because x has to be greater than 0. That was the restriction we had on this function when we started. So we can't have any negative values. So I'm going to go ahead and circle the positive sign. We're going to ignore the negative square root of negative x plus 2. In other words, when I rewrite this, you go ahead and bring the y down. I end up with y is equal to, and since I'm only writing the positive, it's going to be just the square root of negative x plus 2. Notice I didn't put minus square root of negative x plus 2, because our restriction of x is greater than or equal to 0. We're almost done at this point, and now we're going to go to our final step. So our final step, step 6, is we're going to write the final answer using function notation indicating that it is an inverse. So that y that we had converted from f of x, we're going to convert it back to f of x. The only difference is, because this is now an inverse function of what we started with, we're going to go ahead and put this little negative 1 over the f of x. And that represents to any mathematician that this is an inverse function that we created. So we have f of x, right, to the negative 1 is equal to the square root of negative x plus 2. And that is our final answer.